let's go ahead and start. So first of all, this is what we're doing today. We're going to finish up the properties of real number collaborative that you guys were working on last class. Let's go over that. And then we're going to work on accuracy, precision, and estimation, which is going to be the next handout we're going to go through. And then there's a little application about that afterwards. And then negative exponents and scientific notation. So those are the kind of things we're working on today. Friday, there's this growth mindset article you guys all got last class. It looks like this, right? You have to read this by Friday. So it's 6 pages long. And then there are some questions that I'm going to hand out to you guys before the end of class for you guys to fill in. And just, it's like 3 quick questions about it. Not quick, but 3 questions about it. And make sure that you answer those questions in a way that I know that you reference, one of them references something specific in this article. Right, so it's clear that you've actually read it. And you're not just making stuff up. Does that make sense? Everyone on board? Otherwise I'll kick it back to you. And you won't get credit for it. Monday, you also have your My Open Math first assignment. First assignment's due. So hopefully all of you guys have signed on to My Open Math. It's that free online homework that I emailed. It's in the syllabus, and I also emailed you guys a link. So everybody got the emails that I sent out on September 7th or 8th, and the ones before that. So those links are all in there, with also the code, the registration code for our course. It's free. So those first 2, this is just an orientation assignment, and then the first actual assignment is due. Those are both due on Monday. So make sure you get those done by Monday over the weekend. And then Wednesday you have your next homework due. So pretty much every, probably 2 or 3 times a week there'll be homeworks due. In the beginning it'll be 3 times a week because you have nothing due this week. So it'll be 3 times a week until we kind of catch up with that a little bit. So actually it must be 3, and then right after exams usually there's you have nothing for a week. So it balances out that way. Okay. Great, so let's go ahead and take a look at what we're working on here, which was this one here, properties of real numbers. So we've done one. Oops. A little bit touchy. We've done problems 1, 2, 3, 4, 5. I think did we actually do 5 in class? Yes, I think we did. And I think where we left off was, I can't remember if we did 6 or didn't do 6 yet. Oh, actually, we did do 6 and 7, yeah. So the only 2 things we haven't done yet are 8, and then 9, 10, 11, 12. So let's go ahead and take a look at those. Very last page. Well, let's just take a look at them. Let me do it this way. All right, so number 8, distributive property. I think I did this one actually in class. 4 times w minus 12. Okay, and you take the 4 and you distribute it, multiply it by the w. You take that 4 and you multiply it by the negative 12. So you end up with 4w minus 4 times 12 is 48. And then B, was negative 3. So again, remember that negative goes with 3 times A minus 2B plus 7. So I have the negative 3 times the A, negative 3A, negative 3 times the negative 2B. Remember, a negative times a negative, it undoes the negative, so it's a negative negative, which makes it a positive. So it's plus 3 times 2 is 6, so 6B. And then negative 3 times positive 7 is minus 21. And then the last one, C, negative 8x times x minus 3. So negative 8x times another x is negative 8, and then I have x times x, which is x squared. And then a negative 8 times negative 3, negative times negative is a positive, so it's going to be positive 24x. Good? Questions on that part? All right, so let's take a look at number 9. State and words the cumulative properties of addition and multiplication mean when adding or multiplying real numbers. Anybody have a... Yep, go ahead.
It means adding or multiplying the same numbers twice, but in the opposite order.
Yeah, it means, yeah, so cumulative means that you can add, you can add numbers in opposite or other orders. Yeah. Right, so example like 3 plus 2 is the same thing as 2 plus 3, right? And if you have several things like 5 plus 3 plus 2, you can do any order you want. You can do 5 plus 2 plus 3. Doesn't matter, you can move some of them around. Right? Thank you. How about 10? The associative property.
Oh, if you move the parentheses, it will be the same answer?
Yeah. So, so moving the parentheses really means like grouping, right? So it means you can group addition or multiplication, right? So group different numbers in addition or multiplication, but almost do addition. So in other words, 5 plus 3, if you do the 5 plus 3 first and then add the 2, it's the same thing as if you did the group the 3 plus 2 first and did that first and then added 5. Again, it kind of speaks to the order part, right? Great. And then 11, commutative property applies to addition and to multiplication of real numbers. Does apply to subtraction of real numbers. So commutative means you can move them around. So if I have 7 minus 2, is 7 minus 2 the same as 2 minus 7? Can I do that? So nope. And there's an example right there where it doesn't work. Does that make sense?
Mm-hmm.
And then for 12.
Oh, I have a.
Oh yeah.
For 11.
Oh yeah. Go ahead.
So 11, it's the answer is no if the numbers are different, but if the numbers are the same, the answer is yes. So
Well,
3 divided by 3 or 3 minus 3.
True, but a property. But the thing about a property
Yeah.
is a property should apply all the time to any numbers. Do you know what I'm saying? It's like saying, well, will the key to my house work in your house?
Yeah.
Work in other people's houses? As a general rule, the key to your house should not work in anybody else's houses. Does that make sense?
Mhm.
But it might be that there might be one house out there in the world where your key will work. Does that make sense? Besides yours?
Mhm.
So, as a general rule, does it work? Can you do that for any? So a property means you can do it all the time. You can always switch them. So, let me show you what I'm talking about.
Right, here you.
Here, whoop, hold on, stop, let me get through this. You can always, with addition, group different numbers and they'll be equal, always.
Right,
That's a property.
oh,
Does that make sense?
okay.
You can always do that.
Mhm.
With this one here, you can always add numbers in different orders. I can always flip the 3 and the 2 or any other numbers I want, move them around, and it will always be equal, always.
Mhm.
So that's what the property is saying, is you can always do that. So if you're adding numbers, a bunch of numbers, it doesn't matter which order you add them in, you'll still get the same answer. That's what the community property says. You can always do that. Does that make sense?
Okay.
Always, yeah. Property says you can always do that. Now, it's not just sometimes that this is equal. It's always equal. Let's be clear about that. Does everyone understand what I'm saying? It's always true that if I take these numbers and I'm adding them, I can mix them up and add them in different orders and I'll always get the same thing. Always.
Mhm.
That's super powerful.
Okay.
Same thing's true with multiplication. Maybe I should give you guys that example too. So here, I can do 2 times 5 times 7. That's always going to be equal to 7 times 2 times 5. I should rewrite that. Sorry. 2 times 5 times 7 is always going to equal to 7 times, 2 or 5 times 2, doesn't matter. I can put them in any order I want.
Mhm.
And they'll always, always, always be equal. Good?
Yeah, I got it.
Yeah.
Oh. Thank you.
Sure. Yeah, thank you. I appreciate that clarification. Same thing with division. Is 6 divided by 2 the same thing as 2 divided by 6? No, totally not. Right? This is 3. This is 1/3. Totally not the same thing. Right? Good? Okay. Cool. Let's take a look at number 12. So 12 says the associative property. Does that apply to division and subtraction? So in other words, I have 7 minus 5 minus 2. Parentheses around these guys. Is that the same thing as this 7 minus 5 minus 2? What do you guys think?
No.
I'm getting people saying nodding no. Right, because this is, if I do this one, this is 3. This becomes 7 minus 3. And this one becomes 7 minus 5 is 2. 2 minus 2. That's totally not the same. Right, so this is 4. That's 0, so no. So everyone see where we're going with that one? Is, and the same thing works with division. 8 divided by 4 divided by, let's say 4. Let's keep thinking numbers simple. Is that the same thing as, sorry, we'll do these guys first. So that's the same thing as 8 divided by 4 divided by 4. Let's see, 8 divided by 4 is 2. So 2 divided by 4. And over here we have 8 divided by 4 divided by 4 is 1. Good. So this becomes 2 divided by 4 is 1/2. 8 divided by 1 is 8. So that is not equal. That's also no. Make sense? So the commutative property and the associative properties do not apply to division and subtraction. Only to, so you can only move things around or group things differently in addition and multiplication. If it's all addition, right? And you can't mix and match addition, like some addition, some multiplication. It's got to be either all addition, you can move them around, or if it's all multiplication, then you can move them around. And that's like super important to know. Well, it's just useful, it's handy. I should say that. All right, good. So, next we're going to try, we're moving on to this handout. Can you pass these back? Did you guys all get one? Is that enough? Good. Great. Okay. Let's get a reader for this one. How about, David, go ahead and read the first paragraph again, or the first sentence and paragraph.
Okay. Have you ever heard someone ask for a ballpark figure? What do they mean? The phrase comes from the American game of baseball and is likely an extension of the somewhat earlier in the ballpark, meaning within a reasonable range, and out of the ballpark, meaning beyond a reasonable range.
You can skip the source, don't worry about the source. Right, so in the ballpark, it's reasonable range. Out of the ballpark, that's far, yeah? Next, where's this box? Can you read the next paragraph?
Mathematicians deal with numbers. Ballpark figures or estimates can be a useful tool when performing computations.
Mm-hmm.
There are dangers in rounding off or using estimates when performing calculations. Yes, in rocket science, for example. While you may not be planning to major in rocket science, understanding the importance of precision and accuracy can be just as important for managing your finances or figuring out the surface area of the exterior of your home as it is to an engineer or scientist.
Right? In your lives, you're all going to have to sort out I know you guys are maybe far away from retirement, but yeah, you got to start thinking about your retirement earlier, and planning things like that, buying a home eventually, stuff like that, even buying a car, right? You're also going to have to sort out things like, eventually when you have a home, or if you have a home already, like painting it, doing things like that to it, it all involves some calculations. So you're going to look at precision versus accuracy. In everyday speech, people tend to use the words accurate and precise interchangeably, but in mathematics actually have different meanings. So I didn't bring rulers today. So if we were to measure this line below, all of you guys would get similar answers, but you all might be off by a tiny bit from each other. Does that make sense? Because everybody measures slightly differently, like where they start, where they finish, it all kind of, it's all a little bit, there's a little bit of variation from person to person, tiny bit. So your ability to find the actual exact length is determined by the accuracy of the device you use to measure, right? How accurate your measuring your ruler is. Like some of them might have a wider line or a thinner line. You know what I mean? So you have a wider line. Like where do you start in the line, or where do you do you guys understand what I'm talking about? Mm-hmm. Little lines in it. And also your own ability to use the device. Lasers are often used to measure distances because they're far more accurate than humans are, and human-made measuring devices such as rulers and tape measures. So let's get someone else reading this next part.
Wait, but aren't lasers technically human-made?
That is true.
They have to be engineered.
Right. Sorry. So human-made things like measuring device, like tape measures. I'm not saying that other things aren't human-made also.
Okay.
But yes. Yeah. Excellent point. Right. Not all human-made things are inaccurate. Just ones that we end up using often as well. Shania, go ahead and read on the top there.
When mathematicians and scientists talk about accuracy, they are referring to how close to actual something that has been measured. Because absolute accuracy can be difficult to obtain, they sometimes indicate how far from the truth a measurement may be and still be considered acceptably accurate.
Perfect. Thank you. All right. So for example, a measurement of 5.75 centimeters has this little plus or minus. Right, that means give or take 0.02 centimeters means the acceptable measurement may range from 5.75 minus 0.02 right, 5.73, to 5.75 plus 0.02, so 5.77. If somebody ever works on cars, right, it's really important, like, you gotta get some of these measurements really exact, and there's sort of acceptable ranges you can be in terms of having, I don't know, where you set your
Torque ranges.
yeah, things like that. Right, I don't know them offhand, but I know that they exist. I've seen problems with them. That plus or minus 0.02 centimeters is referred to the tolerance, right? So put it another way, if our measurement comes in at 5.74 centimeters, then we're kind of in the ballpark or in the acceptable range of accuracy. It's within the tolerance, we'd say. It's common to see tolerance used when seeing the results of public opinion polls. This is called the margin of error. So in other words, a lot of times you'll see a poll and they'll say, so-and-so is winning, like, I don't know, like Biden has an approval rating of 46% with a margin of error of 2%. That means that they're accurate within the 2% either way, right? It might be 2% higher or 2% lower, but anytime you take a poll, you're not measuring the entire country, so there's going to be a little bit of a range of inaccuracy in there as well. So next page. So you notice so far we have not used the word precise. Oh shoot. I'm actually going to skip that part too. I'm sorry. If you want, we can come back and do that. Do you guys want to do that next class? I can bring in some rules and we can measure those. Okay. So we'll do that next part.
There's a measuring device on their phones that you can measure stuff with.
There is what?
There's a measuring thing built into iPhones that you can measure stuff with.
Oh.
I don't think
You want to
I
try
have.
that? Does that may have, or you can even you might be able to Google ruler on your phone possibly. Does everyone have a phone with them?
Yeah, but I don't think I have that on my phone.
That's okay, but either way, if you try Googling ruler on your phone. That'll have to make it more interesting if if you're all using different sort of things. I'm going to try Googling ruler.
Just ruler?
Actual, yeah. So then you might get the thing that says actual size online ruler. So make it that. Under Google.
Yeah, I see that.
Yeah, so this is what mine comes up with. Yeah, so click on that. And it looks like you can actually measure stuff. Shouldn't have to, does it make you install it?
What?
How do I use my phone as a ruler? Open the phone, open the app. Oh, okay, so open the,
Type in a number and get a name.
wow, you can point your phone at things to see how big they are, how far away it is. That's using LiDAR sensor. I'm not sure you can do that because you might have to, well, maybe you could. If you bend the paper, yeah, so that could work. If you bend the paper and you hold it at one edge and you point at the other edge. Okay, do you guys want to give that a try now, or do you want to try it next class when we have rulers as alternatives for people?
It's not working.
Okay, we'll try it next class. That way people can use a variety of options. We'll have multiple options for folks. So what we're going to do is we're going to hop down to significant digits. So towards the bottom of the page, significant digits. I'll slide down there myself. Let me see what I'm talking about.
Oh, like sig figs in chemistry.
Right. I completely wiped out. Okay, no worries. So looking at this bottom part of the bottom of page 2, significant digits. So So a second numerical type of precision has to do with the number of significant digits you have in your measurement. A measurement of 2.5 centimeters has 2 significant digits. Right? If it's 2.5, this is not coming in, but if it's 2.5 centimeters, that's 2 significant digits. A measurement of, so this is 2 sig, I call them sig figs. Sig figs. Whereas something where it's 2.503 centimeters would have, anybody want to guess? How many significant digits this one has?
4.
4, yeah, 4 sig figs. So there are some rules about sig figs, and I'm going to let you guys do this in a group together. So, U3, again, in a group, U4 in a group, and then the 4 of you guys in a group. So if you can maybe scoot over here, and if you can kind of pull your chairs over here. And I'm going to have you guys take turns, one person in a group reading each of the rules. Rule 1, 2, 3, 4. Does that make sense? And then go ahead and work through the exercises together. Okay, so pop into your groups. Read.